In this section, we'll be looking at the volumes of prisms and cylinders. The formula is very simple. The area of the base times the height, whether it's a prism or a cylinder. Remember, with the prism, our base will be the side that's not a rectangle, unless all of them are rectangles, and in which case you can choose any side. Now, also with this, you might be more familiar already with the formula for a rectangular prism, which is length times width times height, which you could use if you prefer. So here we want to find the volume of this triangular prism. So thinking of the formula for volume as being base times height, we'll first look at our base, which would be the triangle because it's not the rectangle. Since it's a triangle, we use the formula 1/2 b base times height, but this is a different h, so be careful about that. But this base here, notice, would be the a times 8 if we're looking for this. So we need to find that a before we can go on. Notice this 17 over on this side would also be the length of this side right here. So we have a triangle here with sides of 8, 17, and a. So to find a, would be a squared plus the 8 squared equals 17 squared. And that's going to come to a length of 15. So we can plug that in, and that will give us a base of 60 square centimeters. The height of our prism then would be this side over here, the 13. And so for the volume equals base times height, our base was 60, our height was 13, giving us 780 cubic centimeters, or centimeters cubed, and we want to clearly mark our answer. In the next problem I have a cylinder, so I want to find the volume of the cylinder. Again, think of it as base times height. We think first about our base being in the circle. The circle would be pi r squared, and we're dealing with a radius of, well, this is 5, that would be the diameter, so we need half of that, 2.5. So pi times 2.5 squared. The height then would be the other side. Notice we don't have that right now. The 13 that was given to us is a diagonal. But since this is a right cylinder, we would have a right triangle in here with a side of 5, side of our height, and a 13. Again, using Pythagorean theorem, we'll find that that h is equal to 12. So we can plug those into our formula. I'm just going to keep my base as this whole thing, 2.5 squared. Plug it all into my calculator at once. Multiply that by 12, and that will give me 235.6, I'll round to the nearest tenth, and cubic inches. The next concept is called Cavallari's principle. And Cavallari's principle is talking about if we take any stack of something, if I just push it over to the side and kind of make this side slanted, think about this as a stack of quarters, stack of coins. Notice that the thickness of this wouldn't change. The height of it wouldn't change. Now, this diagonal over here would get longer, but since we're looking at this as the height of several quarters being stacked, that thickness is going to be the same. And the same thing if I had a stack of Post-it notes or something like that, if I could push it off to the side like that, my thickness, this side here, would still be the same. That would be my height. And also the volume of these wouldn't change. I'd still have the same number of pieces of paper. I'd still have the same number of coins. And so the volume doesn't actually change if we just push it off to the side like that. And so we're still going to use the same formula, volume is equal to base times height. The only difference is we need to make sure that our height is perpendicular to the base. And so my base here is going to be the circle still. So pi times 4 squared, or 16 pi. And my height would be the vertical here, making sure that it's perpendicular. And then I'll end up with a volume of 16 pi times my height of 9, which will give me a volume of about 452.4 cubic yards. The next problem is dealing with a composite figure. Sometimes we have several pieces. We have this larger shape which is made of a prism here where we have a half circle on the end. And so we want to think about this in its two parts. Actually, we could do it in one part. Well, let's think about it in two parts here, the way that they've split it up here. I could think about the volume first of my prism, and then think over on this side about the volume half cylinder. Now in both cases we still want to think about our volume as being the area of the base times the height. So for my prism I can just think about this. We could think about our shortcut just using length times width times height. But if I look at my base here, so my base would be this part down here. I could go with 24 times 36. which will give me 864, leaving me with a height going the other way of the 24. And so my volume of that prism would be 864 times 24, or 20,736 cubic inches. On the half cylinder then, I would want to think of my base as being a half circle. So think of my base, a half circle, be 1/2 pi times my radius squared. Looking up at that picture, the side is 24, so my radius, which is actually marked, would be 12. Or that would also give me 72 pi. My height of that one is also 24, so if I want to find the volume of my half cylinder, it's going to be my base of 72 pi, which we already took the half there. We don't have to worry about this being a half cylinder anymore. Our base is a half circle. We multiply it by our height, and that's going to be about 5,429. I'm going to round it because they ask us to round to the nearest cubic inch, so I won't leave a decimal there. Our final part then, the volume of the whole thing, will be to add those parts, giving us a total volume of 26,165 cubic inches.